I'll do a lot better. We're going to start off with a few definitions. Data are measurements or observations that are gathered for an event under study. Okay. Statistics is the branch of mathematics that involves collecting organizing, summarizing, and presenting data and drawing general conclusions from the data. Okay. A population. Yeah, no, that's fine.
I'm sorry.
No, you're good. Okay, so the first one we have data are measurements or observations that are gathered for an event under study. Guys, that's just the, like you're going to see they may give surveys out to certain things. Okay, like when you guys did the course survey, okay, they're collecting data. That's what they're doing.
Same with the wellness grant.
Yes. Okay. Statistics is the branch of mathematics that involves collecting, organizing, summarizing, and presenting this data and drawing general conclusions from the data. So what we do as a statistician, is we go, okay, here's all this data, we collected all this, and then guys, it's really just, we're really nosy people, and then we start drawing conclusions about all this information that we got based on this population of people. So it's like you're doing research inside a population of people, which then gets us to what a population is, okay? And a population consists of all subjects under study. Guys, that means everybody in the study. Like a population would be all the students in TJC, okay? All the population is the entire student body. And then if we pull a sample from that population, it's a certain group. Maybe we look at all first-year TJC students, okay? That we call it a sample, and that group that we pull out needs to be big enough that any information that we get from that group can represent the whole population, okay? So a sample is a representative subgroup or subset of a population. And you'll notice there's a couple of vocabulary words from Unit 1 right there when we talk about a subset, okay? All right, so we pull a sample from a population, and there are different what we call sampling methods, okay? Let me So we have sampling methods. Okay. Now, here's the deal, guys. When we do any kind of sampling, we need it, in order for it to be valid, it needs to be what we call a random sample. Okay? And in a random sample, each subject of the population must have an equal chance of being selected. Okay? Each subject of the population must have an equal chance of being selected in a random sample. Now, there are different types of random samples. Okay? We're going to talk about 3 different types, and then example 1 down here asks you to determine which of the 3 types it is. Okay? Then they also ask you, would it be a good random sample? Okay? So, we have what we call a systematic sample, which is selecting every kth member, and I'll tell you what that means in just a second, such as every third member. Okay? Where you could, for example, if you go to a very large D1 university, some of those general studies classes will have, in a lecture hall, you'll have anywhere from 100 to 200 people in one class. Okay? Let's say that you wanted to give an exam in that class, but you didn't want to give the same exam in the class, and then you didn't want to just pass out every other person gets a different one. What you could do in a systematic sample is you pretty much number everybody in the class, and then you go, okay, every third person gets this type of test. Every fourth person will get test B. Every fifth person in the room numbered off out of those 150, 200 people get test C. That type of thing. So you've got a large group, they're numbered off, and every third member, every fifth member, every 10th member is chosen. Yes?
Okay, so how would you do the ones in between? So like what about the first and the second?
It's made where, you then design it where everybody gets something.
Okay, so like
Yeah.
after you pick the first group, then it goes to the second.
Then you can, yeah.
Okay,
Um, typically, that's not how it's done in that large of a class. That was just what popped up. Pretty much everybody takes the same test, and they take it in the, like at A&M. If you are taking a Calculus 1 test, even if your class is at 11 a.m. in the morning, you will sit for a test at 7 p.m. that night. And you, along with everybody else that's in Calculus 1, so it could be 300 other people, will show up at a certain lecture hall. Everybody takes the test. They have graduate students that proctor you. You turn it in, and you won't know most of the people in the room because they're not who you're in class with. So that's how that usually goes. But that's not a systematic sample. We see systematic sampling like in the prison system often. The people are numbered. Every third person will then, if we have built, say, a new block, a new cell block, and we're moving people, this is not how they do it, but every 10th person moves to the new cell block. Okay? That type of thing. We also have what we call a stratified sample. population is divided into groups that have similar characteristics. And numbers, members, I'm sorry, and members, not numbers. Eraser was too big. From each group are chosen at random. Okay, the example that we have for that, for stratified sampling, is, for me, it's easier for you to understand it if we talk about school systems in the state of Texas. We know that schools are classified by size of their high school from 1A all the way up to 6A, okay? Take, for instance, Lenasia, you probably had, how many people did you have in your graduating class? Probably 500 or more? Did you go to a 6A school?
800, I believe.
800? So you went to a 6A school. Because she's got 800 people a class.
600.
600? Yeah, you probably still went to, it was close to being a 6A. If it was a 5A, it was a large 5A school. So she had 500 people per class. That is 2,000 students in the high school alone in grades 9 through 12. Okay? So stratified sampling is, okay, all these schools are 5A schools, and we want to know in education how children perform on this particular math concept. So what they'll do is they'll random sample out of so many 5A schools, so many 4A schools, 3A, 2A, 1A schools, and look at the performance of those students. All those students pretty much are in the same age category. They're all ages pretty much 14 to 18. Sometimes you have older in high school. Sometimes you have a little bit younger, but everybody is under the age of 21 in high school. You have to be, or then you go away. When you turn 21, they make you leave. They seriously do. That's a law. Same thing for middle school. That's why even if a student should be retained in middle school, once they turn 16, they no longer can be in middle school. They have to be socially promoted to a high school campus because there's some legality issues with someone that is 16 going to a campus with someone that is, say, 12 or 13. And most of you understand at your age why there's legal issues that happen. Same thing with if you're still in high school, when you're 20, on your 21st birthday, you no longer can come to campus because you have members that are under 18 years of age, okay? Anyway, a stratified sample is one where they're classified into groups, then we pull samples of people from each of those groups. All those groups that we pull, it is a random sample because they all do represent the population that we're looking at. We're looking at student math scores across the state of Texas. They're all pulled from a high school, but we pull so many from the 5As, so many from the 4As, 3As, 2As, 1As. Okay, so they're clumped together. Then we can also, honestly, when we do a stratified sample like that, you can then go, you can start looking as a statistician, you can go, oh, well, these kids over here perform better. Well, those kids all came from 3A schools. That's interesting. You know, what factor? Is it an environmental factor? Is it a class size factor? Is it, and then you break it down and go, okay, well, what kind of 3A schools? Was it all 3A schools? Was it more economically advantaged schools, disadvantaged? So then you can start making other conclusions and assumptions about that based on the data. Okay? cluster sample. And if you have to take statistics after this class, you will talk about all of these things again in Unit 1. The beginning of Unit 1 is all about different kinds of sampling. I think we even talked about more than these three this semester. There's lots of kinds of sampling. When an existing group of subjects that represent the population is used for a sample. Okay, that, guys, a cluster sample is kind of like, okay, you want to find out something about, say you got a new business and you want it to come to Tyler, but you really don't know if that business is marketable in Tyler. But at the time that you're trying to make that decision, the fair's going on in Tyler. And you go, okay, instead of going door to door to hand out a survey or try to talk to people or go somewhere, you know what we'll do? We'll just go stand out at the fair, and as people come in, we'll get them to scan this QR code and see if they'll answer the survey. That's cluster sampling, because you're using a group that's already put together. And you're also basing that on the assumption, now in Tyler it's probably okay because you have a large population of people where pretty much everybody likes to go to the fair for something at the fair. Okay, so more than likely you're going to get a representative sample of the population of Tyler. Now, if it's in a smaller town and everybody doesn't go, or if it's in a if it's in a town, say maybe that's extremely religious, and let's say at the fair they serve all kinds of alcohol, and then so your extremely religious people may not want to go there. So you may not be pulling a representative sample of that community if you know for a fact that a certain population does not go to the fair, okay? It needs to be, if it's a true cluster sample and a good one, you need to know that pretty much everybody in the population is going to be represented in that sample. So that brings us to example 1, and it says a marketing firm is hired to study the occupants of a medium-sized town in Ohio to see if a chain restaurant/brewery would be popular there. The company considered 3 different methods for gathering data. Describe what type of sampling method they're using in each case. Then describe whether you think they're likely to get a representative sample. This actually reminds me of when we were still living back down towards Houston. We had Craft 96 come into our town. It is a brewery type restaurant is what it is. But given the population of the town that I lived in, which most of the income there of those families is based off the 3-4 oil refineries that are in that town, and that population of people that typically works at the oil refineries, we do drink. And it's beer. And so Craft 96 has gone over really well in that town because it is a brewery with a restaurant. They also then opened another restaurant called Cactus Jack's, which is very marketable to the clientele that's there. But seriously, before a restaurant comes in, they do look at the population in that town to see if their business is going to be profitable. Because, guys, there's no sense dumping a lot of money into a business in a town that nobody in that town is going to want to go to, okay? That's just how business works, okay? So what they want you to do in this question is they've got ABC. You're supposed to match that with one of the types of sampling we just discussed, either systematic, stratified, or cluster sample, okay? So A says they're going to pass out surveys at each of the churches in town. Would this be systematic? Would it be stratified? Would it be a cluster? What do we think?
Cluster?
Close.
I think it's true.
Going to be stratified. We know it's not systematic because nobody's numbered the churches off, right? Okay. It is stratified because they are thinking that, okay, the community's all divided into different churches, so then they're going to draw a sample from each church, okay? Like I said, you guys don't have to write this down. It will be posted for you. You can just write down the answer. So you can put like A, stratified sample. And then it says, describe whether you think they're likely to get a representative sample. Do you think they're likely to get a representative sample? I'm going to say no. They also said no because the only people that you're surveying are people that go to church. There's going to be a population of people that do not go to church that live in that town, if it's large enough. And it said it was a medium size. No, only people who attend church will be surveyed. Okay? B, mail a survey to 4 houses on each street in town.
Systematic.
It is systematic. Very good. Should it be a good survey? Yeah. It's representative of the entire population. They're taking every street in that town. They're selecting the first 4 houses probably. It says 4. They're selecting 4 houses on every street. So maybe 1, 3, 5, 7, 2, 4, 6, 8. Those houses get the survey. They don't check to see who lives in there. They don't check to see how much money the house costs. They don't check any of that. They go, okay, here's 4 houses on this street, mail those. Here's 4 addresses on this street, mail those. Okay, so yes, it should be a good sample. We'll just say yes. And C says pay workers to conduct in-person surveys at the annual town festival. This, of course, is a cluster. It's already grouped there. Now, this response of whether it would be good or not was kind of in question. And textbook says no, it's not good sample because only the people attending the festival, yeah, annual town festival, it's not a fair, it's a festival, will be attending. It's cluster because those people are already going. We don't have to do anything to put those groups together. There's already some people grouping up, going to the town festival, okay? And so that's a cluster sample. We're using that cluster there, but the book says no. It's probably not a good representation because everybody from the town may not go. Now, I'm going to tell you, in a small town, in a tiny town, like I live in Mineola, okay? They have little festivals. It's the Iron Horse Festival, okay? They have this thing called the Iron Horse Festival in the fall, one weekend. All the little local businesses, people set up crafts and everything. I'm going to tell you right now that cluster sample would be a good representation because nearly everybody in that tiny town shows up for something there, right? They show up to take their kids to get free food, to jump on the jumpy things. Okay, like in Lindale, I went to there was one in the fall, and they had a car show there, and then like all the ladies that sell crafts and everything there in Lindale, like set up show. It's not the wine festival. It's a different one. I forgot what it was called. But went this year, they have a 5K race in the beginning and to start it off. Okay, that probably would have been an okay sample of a cluster sample. You would have gotten a representative population because all the little town people come in. Okay, same thing for Mineola. They're saying in this town, since it's a little bigger, no, because not everybody will attend the festival. Okay, that makes sense. Lots of times y'all have, like in Tyler, there's like art festivals or things downtown. Not everybody goes to those. Okay, or say in Houston, like this would not be a good sample in downtown Houston because there are so many different cultures there that you're not getting all the other, there's tons of festivals that go on, okay? All right, that's example one. Let's see, where do we go? What do we do now? Okay, we need a little definition before we do the next problem. It is a categorical frequency distribution is used when the data are categorical rather than numerical. Guys, all that's saying is you're dealing with data that's not numbers. You're dealing with data that is words, letters, types of things like that, okay? And so in example 2, we're going to design a frequency distribution chart in example 2, and it is based off of categorical data because these are letters that represent the types of vitamins that there are, I think. Yeah, vitamin pills. Okay? It's not numbers. It's not numeric based. Yes, I'm sorry. So, example 2 says a health food store recorded the types of vitamin pills 35 customers purchased during a one-day sale. Okay? Construct a categorical frequency distribution for the data. There are certain businesses that do this. One of the main ones that I remember is Hibbett. And I think it went out of business is it still in business in Lindale? It went out of business in Mineola, I know that. But Hibbett will put items in their store based on the population of that town, okay? Such as if you live in a town where Little League Baseball is a much bigger deal than, let's say, soccer, Hibbett Sports would put more baseball attire and gear in their store. But you could then travel 3 towns away and go into a Hibbett, and in that town, soccer might be present more than baseball, and there would be lots of soccer items in that store. And you learn about these kind of things if you're a marketing major because it's about selling. It's about what's going to make me the most money. So this health food store, what they did was they offered a sale that gets more people in, and then they recorded which types of vitamins were most popular that day. So that way, when they go to restock, they're going to go, oh, well, I might not restock vitamin E because, or whatever it is on there, because not that many people bought it, okay? It's sitting there, it's going out of date, we're having to discard it. We're wasting our money. So this wants us to construct a categorical frequency distribution for the data. Guys, that's a real fancy term for saying make a T-chart and show how many of each one of the things is listed there. That's all you're doing. So what we do is we go, okay, we're making our T-chart. We've got our types. That's the left-hand side. And then my right-hand side is going to be the frequency. Guys, what does frequency mean?
The amount.
Yeah, the number of times it happens. Yeah, that's all. Okay, so what are my different types? A, B, C, D, E, right? Okay, when we say types, we're going, okay, what things are listed there? All right, then we go, okay, let's talk about the frequency of each one of those. So I go up there and I count how many A's do I count. I'm going to highlight them a different color so you guys can still see them. Typically, I will scratch them out if I'm doing them just myself. So let's see, how many A's do I see? 2, 4, 6. Okay, so I put a 6 right there under the frequency, because that's seriously all we're doing. If I go to B, okay, so I've got 1, 2, 3, 4, 5 B's. Okay, I would suggest you either I suggest scratching out, and then that way when you get to the end, you'll notice if you forgot one, if you missed one, okay? I'm just highlighting so that y'all can still see things. C, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 C's. That one seems pretty popular. Okay. Let's do D. 1, 2, 3. Only 3 D's. Yep. And then E. I'm just going to circle those. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 E's. And you have built your frequency chart, your categorical frequency chart. Okay? And you'll notice in your little data up there, your little cluster of data, that you don't have anybody that's not highlighted or circled. So you got everybody. You didn't miss anybody. Grouped frequency distribution. Is the numerical, excuse me, data are divided into classes. Okay, guys, all classes is a range of numbers. And here's an example of how we use grouped frequency distribution. If I took a survey or I asked the entire TJC population to record their weight, that I was doing a study of the weight of college students, okay? And you just anonymously put your weight into some Google survey you got, right? No name, no email, nothing. I would have to, when I went to represent that data in a frequency chart, I literally cannot individually list every single weight, okay? It would be too much, right? I've got some little people in here that my daughters were some of them, when they started college, they weighed under 100 pounds. I mean, they get their leanness from their father and their shortness from me. So like a little bitty, they look 12. You know, those of you that are smaller females, you know how that goes. It's like, could somebody think I'm grown at some point? I promise you'll be happy about that one day. One day. It'll take you till about 35 to be happy that they then think you're like 25 when you're 35. But anyway, I couldn't go through there. There's 12,000 of y'all that enrolled in the fall semester. I could not literally go through there and list 98 pounds, oh, there's 2 of them. 99 pounds, there's 5 of them. 150 pounds, there's 220 people. Okay, I couldn't do that. So what we do is we design what we call classes. So it's just a range of numbers. So like I would go, okay, this is 100 to 125. And then I would list the frequency that happened, how many people that was that weighed 100 to 125 pounds. And then I would go 125 to 150. That would be maybe 300 people that weighed that many pounds, okay? So an example, is this example 2? No, 3. All right, good. So in example 3, it says in one math class, the data below represent the number of hours each student spends on homework in an average week. We want to construct a grouped frequency distribution for the data using 6 classes. So the first thing I ask myself is I go, okay, well, what did those numbers go from? They go from, what's my lowest value there? 1. 1, 2, what's my highest one? 18. So I've got to, it says I need to make 6 classes. So I've got to determine how many values, what's my range of values per class. I've got 6 classes. I pretty much have 18 different values. How much does each class need to have? 3. It's going to have 3, right? Okay, because I can go, okay, here's the kids that studied 1 to 3 hours. Here's the folks that studied 4 to 6. Here's the folks 7 to 9, 10 to 12, 13 to 15, and then 16 to 18. That covers everybody. You got to make sure whatever classes you build, all your data can go in one of them, okay? They've got to fit in there. And here's my frequency. So I go back up here to my list of data and I go, okay, I need to know how many numbers there are that either a student studied 1 hour, 2 hours, or 3 hours. Okay, so I go, all right, well, there's 1, 2, there's a 2. I'll go back and count in just a minute. Let's see, 3, 1, 1, 2, there's another 3. How many we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So there are 10 people that reported they studied 1 to 3 hours somewhere, okay, for this test. All right, how about 4 to 6? So I go up here and I look for all the 4, 5, 6s, right? There's a 6, there's a 5, 4, 5, 4, 4, 6, 5, 4. There's a bunch of those folks. 4, we needed a 6. Let's see, we're supposed to get 14. Do I have 14? Did I miss somebody? I think I missed somebody. There's a 6 right there. Oh, no, that was a 9. Hold on. 6 right there.
And 2 5s.
Where's my 2 5s at? Tell me which one. There's
in the
one.
right corner.
In the right corner. Yep, there we go. Okay. All right, so let's see how many blue dots I got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Got them. Okay, let's do 7 to 9 hours. 7 and 9, 7, 8, 9, 9, 9, 8, 8, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, we should be getting 10. Okay, let's do, sure, we'll pick yellow. 10 to 12. All right, there's a 12. Okay, that's not a very popular amount of time there, is it? 2, 4, 5. Oh, I missed one. I should, right beside the 11. Oh, there he is, right there. Yep, and that should give me 6. Okay, then 13 to 15. 1, 2, 3, 4, 5. Did we get 5? Yep. And then 16 to 18, there should be 5 of those also. 1, 2, 3, 4, 5. Yep. And you made what? You made a frequency distribution chart using classes now. Okay. Let's talk about a stem and leaf plot. Last time you did a stem and leaf plot, you were in the 7th grade. Until you took the TSI. If you had to take the TSI, they put 1 on there and you got it wrong because you had no idea what it was talking about. In a stem and leaf plot, each data value or number is separated into 2 parts. Okay? Now, it depends on what your numbers are. So, in this particular example, and guys, it's just an easier way of compressing data, is what it is. So we have these numbers right here in example 2. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's 20 numbers. And we want to write it without having to write down all those numbers jumbled up like that. We need it a little more organized is what they want. So we make what we call a stem and leaf plot. And we assign the stems to be one part. We assign the leaves to be another part of the number. So this one says it's no secret that gas prices have fluctuated wildly in the last few years. But from 1980 to 1999, when you guys weren't alive, more than likely, they were surprisingly stable. According to the Energy Information Administration, the data below represent the average price in cents per gallon of regular unleaded gas for those years. We want to draw a stem and leaf plot of the data. Okay, so I have my numbers go anywhere from something in the tens to the hundreds, right? So my lowest value is an 86, I think. Is it an 86? And then what's my highest value that I have? 131, looks like. Okay. Now, the only thing, lots of times if you have just like 2-digit numbers, the tens values will go in the stems and the ones will go in the leaves. But here I've got all the way to the hundreds, right? But the one thing that whether it's a tens or it's a hundreds, they all have a ones, right? So I'm going to make ones go in the leaves. And the other chunk of the number, whether it's just a 10 or whether it's a 10 and 100, is going to be part of the stem, okay? So here's how it works. What's my lowest value? 86, right? That means the stem, the 8 goes to be the stem. And then I'm making my leaves ones. He's going to be the 6. That's red, 86. Okay. Now, those are the 80s. Let's go to the 90s. So I've used 86. I'm actually going to scratch him out. How many 90s do I have? 2. So I'm going to put the 90 over here in the stem. But now I have 2 90s, so I'm literally going to put 2 zeros down. That tells me this represents 90 and 90. This one, top one, tells me, okay, this is 86. All right, now let's look at, after I didn't have anything but 90. Let's look at 100. Let's look at the values from 100 to 109. Okay, do I have an even 100? Yeah. So I put a 10 in the stem, I put a 0 in the leaf, over in the leaves. Do I have any more values from 100 to 109? I got a 106, okay? So I'm going to write a 6 right there. So this is, do I have any more? Nope. So this is telling me that this represents 100 and 106. There's the 10 with the 0, the 10 with the 6. Okay? Let's go up to 110 through 119. So that means I would have an 11 right here. Do I have a 110?
Yeah, no, wait,
No 110s? No. Do I have a 111?
yes.
How many?
2.
2. So that's a 1, 1. Sorry. 1, 1. Okay. What about 112? Do I have a 112?
Yes.
Yep. Just 1?
Yes.
How about 113?
Yes.
I have 2 113s?
Yes.
Okay, so then I need to put 2 3s. Because I got a 113, 113. Do I have a 114?
Yes.
How many?
1.
Notice I don't put any commas in between those leaves. Okay, 15?
Yes.
How many?
2.
Right, any 16s?
No.
17?
Yes.
1? And 19s? 1, yeah. No 8s, correct?
Yes.
Okay. Let's go up to then 120 to 121. 120 to 129, sorry. So I've got now 1, 2. Do I have a 120?
No.
121? 22?
Yes.
Yep, 1. 23?
3.
1, 2, 3. 1, 2, 3. And then the only thing I have left after that is 131. So I've got my 13 and then I've got a 1. Okay. That's how you do a stem and leaf plot. Now that can change. Like you will have a homework problem that has some decimals in it. So they will probably put that first decimal place as the leaf. Okay? The point, like the tenths place as the leaf. Generally, what they like to do is whatever that lowest place value is, it becomes the leaf. Okay? That was example 4. Example 5. We're still doing a stem and leaf plot, but this time we're going to do it a little bit different. Now, we don't see stem and leaf plots like this very often, but the book does present it this way, so I'm afraid you will have some homework that looks like this. This stem and leaf plot is a class stem and leaf plot, okay? Made from classes, okay? So let's look. What's my lowest value here?
18.
Is it 18? Yep. 18, what's my highest value? 40. Okay, so as far as who gets to be the stem and who gets to be the leaf, it's pretty easy from that who's going to be the leaf. The one spot, place value. I was trying to put place and spot together. The ones place will be the leaves. Okay, so you got the 10s, but here's the deal. We got lots of 10s, and they don't want to really make it that long. So they're going, okay, we're going to bust it up into classes. So we're talking about from the 10s value, they're going to, since we don't have any values 10 to 14, right? The lowest one is 18. So they'll put a 1 right here, and they'll put a little 5, like an exponent, a superscript in parentheses. That means you're looking at the values from 15 to 19, the top half of the 10s, okay? And you go, okay, there's an 8. You took care of the 18, right? Now, it'll become a little more clearer in a minute. So on this next one. So now we're looking, we've moved on to the 20s, right? So we do a 2 with a little 0 at the top, and then we've got a 2 with a 5 at the top. They don't want to put so many leaves on a row is what they're trying to eliminate. I agree. So we've got, that's a 0, sorry. we've got a 2 with a 0. What that means is I'm listing all the values from 20 to 24. Okay? So this was values from, that M got carried away, didn't he? From 15 to 19. This is 20 to 24. This will be 25 to 29. Okay, so from 20 to 24, let's see what I've got. Who all do I have? Just 23? All right, there's my 23. Okay, let's do 25 and above. I've got a 25. I should have a 28. And then how many 29s do I have?
2. No,
3.
3.
Good. 1, 2, somewhere. And 3. Where's my other 29? There he is. There we go. 1, 2, 3. Okay? So then I've got to have a 30 to 34. So that's a 3 with a little 0 at the top. And then a 3 with a 5. 35 to 39. Okay? There are quite a few values in the 30s, guys. This is why they split it into classes. Because you'll see when we do 30 to 34 and then 35 to 39, it would have been a long list of leaves out there. So the values 30 to 34, I have 30, I have 31, 32, 32, 32, 33, 33, 34, 34. Guys, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 values just between 30 and 34. Okay, if we had just listed a 3, I would already be at 9. Now I got to list everybody from 35 to 39, which there's a lot. There are 3 35s. There are 1, 2, 3, 4, 5 36s. There's 1 37, 2 38s, and 3 39s. So what they avoided by busting the 10s pretty much up is writing, how many did I say I had? Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. 23 leaves on one row is what they did. Okay, they busted that up. And then finally, 40 to 44, all I have is 140. And that is all of 11.1.